yeah, come to here. So earthquake, and here is the determination of the zone factor. We decided zone 𝗂𝗧 𝗂𝗧 mainly depend upon the type of rock. Okay, is that rock soil or medium stiff soil? And there is for a soft soil. If it is a soft soil, we need to take from the 𝗂𝗧. 𝗂𝗧 will be, suppose my soil will be rock soil, we need to take a 1/t. How we can decide the t? So this is also main important. The t is a somewhat another, and determine the corrected spectrum used to be estimated. If it is a soil type 1, so rock soil, hard soil, medium soil, stiff soil, and soft soil. Once you go to here, and this is a response reduction factor, page 1, part 1 to 5. And this is just a part 1. Okay, here we have a part 2, part 3, part 4 also. Those part 4s is the type of liquid retaining structures. At the time you can use the part 4 and part 3. And the seismic zone. So here you can see the zone factors. Okay, it's a zone value, and 2, 3, 4, 5. And here a zone factor 0.1 and 0.1, 0.24 and 3.6. And come to the earthquake design, we have a equivalent static method and dynamic method. So come to the dynamic method, we have a response vector method, model time history method, time history method. Okay, so based upon that, whenever if you go for the dynamic analysis, we need to go for the response spectrum and like that. Okay, so and this is a spectrum curve. Okay, so design acceleration spectrum 𝗂𝗧 is the 5% damping. Okay, every time, see, up to only some extent it will be your earthquake will be predominant, but come to the, if your time will be decreased, your spectrum will be decreased. Okay, so and again here is a equivalent static method. We will be used only for the TA less than 0.4. If you have a TA less than time period less than 0.4, you need to go for the equivalent static method. If it is greater than 0.4, you need to go for a dynamic analysis. Okay, even here also one of the important thing. So RC masonry of the structure, 70% of the eye gross of the column, 35% of the eye gross of the beam. I hope see this where we need to consider this. For the structure analysis, the moment of inertia shall be taken as a 70% and RC column and 35% of the RCC beams. Just go to ETABS where I need to mention this. Okay, just go to define. Yeah, load. So not define. Just go to section properties, frame sections. Let me choose a columns. So column, just go to column, click on modify and show property. Once you click on the modify and show property, you can get all the properties whichever I assign to the column. So once you go for the property modifier, show, click on, see here I will give you moment of inertia for 2 axis is 0.7, moment of inertia for 3 axis is 0.7 as per this IS code book. Okay, IS says for the structure analysis you need to go for the 70% of the eye gross of the column. Okay, this is a somewhat a little technical concept actually. So whenever you are taking the so it will be mainly depend upon the crack resistance. Okay, if you mention as a 1 here, so it will, you are assuming it as a, so my beam will, my column or beam will never get any cracks, but that will not happen in our existing in real time. So maybe our building will get some cracks. At the time you need to give some property modifier as per the IS code book. IS code book says just go for the 70% for the structure analysis. So that's why we took the 70%. If you go for the beams, just go click on modify and show property, and click on modify reinforcement. Oh, not a reinforcement. Just go to property modifier. Here is a 0.35. Okay, so as per this, we need to consider that only. Okay, I hope you understand it. So again, let me show you here. And this is and after that buildings, and here is a definition of irregular. So these table 5 and table 6 is a very important, guys. So table 5 and table 6. So every time how we have two irregularities. One is a plan irregularity and another one is a vertical irregularity. See here. So vertical irregularities. These two important things while we are designing with the earthquake design. Okay, so torsional irregularity. If suppose you have a torsional irregularity, how we can define a torsional irregularity? Okay, so if suppose here the delta minimum. Okay, if you just imagine, so if you apply a load here exactly like this earthquake load on this building. Okay, let me show you exactly. This building will be initially here. Okay, so here, but once I apply the earthquake load, this will be go like this. Okay, here I am getting some maximum and here is a minimum. Based upon this maximum, it will be greater than 1.5 d minimum, delta minimum. At the time only it will call it as a torsionally irregular building. So we need to avoid this torsional irregularity. How we can avoid it? Here only you can get a solution for that. Okay, so if you suppose you have a torsional leg, when the ratio of the maximum is be increased, so we need to go for the increase in the C, guys. I think somewhere here we have some of the how we can we will provide some shear shear walls to reduce this torsional irregularity, or otherwise you can increase the column sizes, or otherwise you can orient the you can change the orientation of the column sizes, and those things we can do, and we can reduce the torsional irregularity. Okay, so and again come to here, and this is a let me discuss in this point of view only, so I don't want to explain you that paragraphs. So here it will be, so this is a re-entrant corners, how it will be. So anytime if you go for the re-entrant corners, so if you go for the L-shape buildings, we can't provide a L shape. Okay, we need to provide some construction drawings here to resist the earthquake. Okay, so like that, and here is the re-entrant corners, here is the floor slabs having the excessive cutouts. If you have a cutout somewhere, you need to provide a cutout exactly this much. So this is also gives you the area of the total, and here, so here A0 is a less than 0.8 total, A length is a 0.A1 total. So like that, and here is the floor slabs with the excessive cutouts, and this is a 3D out of plane action, offsets in the vertical. See this, suppose here we have a column. Okay, so here you make it as a beam, and you place another column here. How it will be? This we call it as a flat means what is that, floated column. So this we need to avoid this situation. So that's why they will told you this is a plan irregularity. So here also, while you are placing the structural walls, you need to provide as a non-parallel direction. Okay, parallel direction. In this exactly straight, I need to provide here at the time the torsional may lift it. Okay, if suppose you are providing exactly like this, somewhere here I provide a shear wall, somewhere here I provide a shear wall, and like that if you provide, so wherever the shear wall having a higher stiffness, that will try to twist like this. Okay, at the time the torsional will act in. So what will happen at this situation? So it will try to bend like this. Okay, here delta minimum will be somewhat higher, and delta maximum will be higher. So it will be leads to 1.5, above 1.5. Then our building may got a torsional irregularity. So it will leads to that, and also come to here re-entrant corner, force have excessive cutouts, and offset element. These are all things, and vertical irregularities also plays a vital role. So stiffness irregularity, how we can make a stiffness irregularity, and vertical geometry, and plan strength irregularity, weak story, floating columns and stub columns. In this see, this feature is undesirable, so and hence should be prohibited. So floating columns and stub columns when it will be acting as a laterally resisting member. Okay, supporting the primary laterally resisting load. If it is a part of the supporting the primary lateral load resisting structure. Okay, if it is only for the gravity loads, the floating column is the best. And if you go for the lateral loads, see guys, one thing I want to tell you, if you suppose say one stick with fixed here, so if you try to twist this one, so then it will be somewhat stiff enough in this downside, then it will be okay. If you are placing anything in the air, you just give some pinned type. At the time, if you just apply anything, it will like this one, right? So this is happening in the floating slabs. So that's why we restricted in the lateral load resisting member. If it is a lateral load resisting, we need to we need to avoid these floating columns, and the vertical irregularity offset, and this is a mass irregularity, stiffness irregularity, mass irregularity. Okay, see this mass irregularity in the sense in the top floor you provide some shear walls, and then in the ground floor you provide columns. At the time it will show you the mass irregularity. So we need to encounter this mass irregularity. Here is also geometric irregularity, vertical geometric, and here is a discontinuity, and here is a story strength, weak story. So weak story is also one of the important, and here is an importance factor. If it is an importance some residential or commercial buildings, we need to take a 1.2, and if it is an importance factor in the commercial community buildings or some school buildings or hotels, at the time we need to go for the 1.5. So and design acceleration spectrum response reduction factor. Okay, so the dual system, whenever go for the dual system, you need to go for, and here is a response reduction factor building. So response reduction factor, suppose sometimes we will confuse within, either we can take the 2 or 3 or 5. So when we will take the 3 or 5, so whenever if you go for an ordinary moment resisting frame, we need to go for a 3, and if it is a special moment resisting frame, we need to go for a 5. So just remember this page number 22, right? So I need to go for the page number 6. So there we can see ordinary movement. What is the difference between ordinary movement resisting frame and frame moment resisting frame. So guys, see this ordinary moment resisting frame. If it is ordinary moment resisting frame, R is equal to 3. So as per the code book, R is equal to 5 in this case. What is the main thing? How we can decide our building will be ordinary moment resisting frame or special resisting frame? Designed and detailed as per the IS 456 and IS 800, but not meeting the special detailing requirements, ductile behavior as per the IS 13920. If suppose you didn't consider the IS 13920 for the detailing, so then it will be over OMRF. Suppose design and detail as per the IS 456 and SP 34, IS 800 meeting the special detailing requirements, IS 13920. If suppose you are considering the IS 13920, we call it as a SMRF. If you didn't consider the IS 1930, what will you do? You can go for the SP 34. Then if you go for the IS 456 and the SP 34, that we call it as a OMRF. Then if you go for the IS 456 design requirements and IS 13920, that we call it as a SMRF. But when we will go for the IS 13920, if suppose you come on, yeah, your zone will be in a 4 or 5. Okay, at the time only you can go for the SP 34. IS 13920. Otherwise, you no need to go for the other. But it will be depends upon the client requirement and that area place requirement. Okay. Otherwise, you can do this. Right now, my building is a SP. I don't want to consider the IS 13920 in Vizag. So that's why I do the general detailing SP 34. That's why I need to take OMRF. If it is a OMRF, I need to go for a 3, right? So I hope you understand it, how we can take it. And the percentage of imposed loads to be considered on a calculation of the seismic weight, mass source. Okay. So if it is the building weight, the load will be 3 kilonewtons, I need to reduce my imposed load 25%. If it is above, so I need to reduce my 50%. When we will go for this and how we can give in a ETABS. If you go to here, so in the, let's see in a ETABS. So just go to define. Okay, mass source. Where is the mass source? Here, mass source. Here, just click on modified show. Here, I give it as a dead load and HDL live load. Live load, I give it as a 0.25. Why I give it as a 0.25? So my load will be including 3 or up below 3. So that's why I took it as a 0.3. This only when we will reduce this imposed load. Whenever we go for the earthquake analysis, then only we need to reduce this. If you go for the wind load analysis, we can't take the mass source. Mass source will be never predominant in a wind load. So mainly earthquake loads, you need to take this mass source. Okay. So like that you can take it and also come to the region and exposure and again design horizontal. These are the members and time period. So this is a one important thing. Yeah, this is a formula. VB is equal to H into W. Design all the buildings. It's a with the brickwork and without brickwork. See, here is a bare frame with buildings without any masonry. If suppose your building will be this one, so you didn't construct any masonry wall, only beams and columns and slabs. So you didn't construct any walls. At the time, you need to go for the time period. This is a formula. If it is a steel structure, this is formula. If it is a steel MRF, so this is a moment resisting frame. This is a formula. If suppose you are providing any staircase, this what is a brickwork, then you need to go for this formula, H by D square. H is a height of the building and D is the base width of the building. So suppose it's the base width, some 20 meters of building it is, then you need to take here and then you will decide the time period. So how we can give this all the input? So where we need to give this all input. So yeah, for this define, go to load patterns, earthquake. Oh yeah, earthquake, modify lateral load. Once you click on here, see this earthquake X direction. So this is the zone factor and here is the soil type. And the importance factor, it's a residential building. I need to take a 1 only. So here is a time period. So based upon that formula, this formula will give you this value 0.03434. Okay. So this is a response spectrum R. Okay. And here is a floor. Here I need to take as a floor level. Why? Because earthquake will come from the ground. Okay. Okay. That's why I need to take a footing level also. It's a top floor. So like that we can give it. And here also we have approximate and program calculate. Program is also calculated. So that is the main thing. And again, come to here. and this is how we can calculate, and these are some of the important options, and this is a response spectrum, how we can do it. And here base shear calculation, if you suppose when we will do the base response spectrum, there base shear for the response spectrum will be different, and the static will be different. At the time you need to correlate those things, so you need to multiply with that, then we need to do that. Okay, that is the dynamic analysis response spectrum. And here is a mode shapes, when we will, how much is a mode shapes, and what is the frequency is equal to T is equal to 1 by F. If it is a F is a 33, then we will get a 0.3 seconds, that is the frequency. And how much is a mode shapes we need to take, how many mode shapes we need to take, so that thing also we need to learn from here. And this is if suppose you are going for the brick masonry, this type of will affect on our building, so that's why the time period will be may going to change. So, and here is a story drift limitations, some of the limitations also we have. So here, and capacity of the non-sink, and this all the, see, this is a maps for the some type of here capacity of the tectonic features. Okay, the tectonic plates may leads to the earthquake. Okay, and we have some epicenter and those things also, where we will get a epicenter and these things. And here is these all the important information we have. And again, if you go to here, I hope whatever the important concepts we need to learn, and we told you. And here is based upon this in manual calculation, so zone factor, these all things we need to get from that code book. And once after that, we need to calculate all the manual calculation, how much is the weight of this building will get, so how much is CAR. So my floor, on the floor weight, self weight will be, so to 682 kilonewtons we are getting. Okay, so after this we need to multiply with that one. Okay, after that we need to go for the IS 16700 2017 structural safety of the tall buildings. So whenever if you go for the main thing is general requirement of including the height limitation of the different structural system, elevation and plan aspect ratio, lateral drift and story stiffness and strength, density of the building, and modes, vibration and floor system, materials, progressive collapse, those all things will be included here. And if you wanted to go for the US codes, this is a ACC 710 is a minimum design load for the structure. There we can get a lot of structure, lot of information in that US codes. Okay, so some of our codes will be take the inputs from the US codes also. And ASCI 318 is for mainly for the RCC structures in American codes. Okay, so and here is the RCC building greater than, if suppose your building is higher than the 50 meters but less than the equal to 250 meters, we need to follow this code book. If it is higher than 50 and lesser than 250, if suppose you are going for the 250, what you need to do? If your building is a height will be, you're having some crores of rupees, you wanted to go to build a 300 meters of height, what you need to do? So here they mention it. Okay, this standard is not applicable with the tall buildings located in the near field of seismic faults. So, and the standard applicable only for the buildings with the houses are 2 feet. The standard may also design the, so if suppose you are going to 300 meters, they will told you some information regarding that. So if it's not applicable, you need to consult, and otherwise you will take some other code books like that, they will mention. And here is this standard is not applicable for the design of buildings height more than 250 meters. So this is if suppose if you are trying to construct a Burj Khalifa in our India, what we will do? So Burj Khalifa is 800 plus meters. What will you do? So our code book is only for the 200 meters, 250 meters. So that is what we need to do. We need to update ourselves, and we need to do a lot of hard work to do these things. Natural period, as time taken by the structure to complete one cycle of oscillation in its natural mode of collision. And if you suppose when we are in physics, then we study the pendulum concept. Okay, how much time it will take to oscillate, that is the natural time period. That is also apply here. And gravity columns. So gravity columns is not participate in the lateral load resistance. Gravity column and float column, the stub column, these all will be like that. And stall structure building height greater than the 50 meters but less than the equal to 250 meters. That is called with tall buildings. Super tall buildings of height is greater than 250. So Burj Khalifa is a super tall structure, like that we can call it. Okay, height limitation, story structure, and table 1 and slenderest ratio, and the plan aspect ratio. How much is the plan aspect ratio? It will be must be 5 meter 5. Okay, then the story stiffness and strength. How much is the 70% of then the story above? So these are the information. And the lateral drift, how much is the drift under vertical acceleration. Table 3, natural mode of vibration and the natural frequency of floors and acceleration. Wind effect, width greater than 150, wind lesser, and here a lot of information will be here. So but even though it is also, see this cracked RC moment of inertia. So whatever the moment of inertia we discuss in ISO 1392, the same thing will happen here. So if it is a column, it is a 0.7 and 3. Here they mention you use slabs also 0.25 and walls, shear walls also 0.7, and the second order deformation effect P delta. So P delta is also main important while you go for the non-linear or static analysis. And the direct load path and backstage load path. So this is mainly deals with the high-rise buildings. So when you go for the podium type and retaining wall, we need to construct. This all the information we can get from here. The type of building is a type. You see, it's also told you just follow the IS 1893 table 5. It is also not giving you the complete details. It will also told you to go for the some that building, okay, that type. So and here is the seismic requirements of zone 2, and the thickness of the structural wall shall not be less than 200 mm. So thickness of the structural wall, if you go for the shear wall, so as per the IS 16700, you need to go for the 200 mm. Okay. So and here the plan aspects of the tube and tube in tube structure and the depth of the foundation, how much depth we need to provide, and podium type of designs. Podium in the sense the downside. So if you come to here, this type, this here we call it as some podium type. Okay. So there are a lot of options will be here, and we need to study all these options. And this is somewhat whenever we go for the high-rise buildings, but initially we didn't use these code books actually. When we go for the G+5-story building, we don't need to use it. IS 13920 is enough. And after that, we need to go for the SP34. Okay, before that, let me show you that what is the SP34 is a wonderful book actually. So whenever if any freshers will be there, you need to study this SP34. So this is for the detailing. Okay. So this is mainly for the detailing. So even if you go for the steel detailing, detailing of function, all these floor slabs, column, beams, floors, staircases, how we can detail, and these all things. And here is the diameter tolerance percentage, and also here is the requirements for the reinforcement bars, and again tolerance. And this is, and again let me show you some important concepts in this also. Yeah, this is a sheet actually, sheet arrangements it will tell you. And these are the some hook. Okay, how much is a hook, how we can give you the bar bending schedule. This is a general one example. Some in this beam slabs are similarly arranged in this way. And always whenever if you go for the detailing, it must be, you need to go from the B1, B2 and PB1, plinth beam 1, B2, B3, like that. You need to go from the top to bottom and left to right, like that we can go. And again, if you see, so this is the development length formula. This is already we calculated in IS 456, and this is how we will. This is a main important 5M thick, and how much when we go for the BBS bar bending schedules. There we need to consider these values. Okay, how much is the length we need to give that anchoring. These all things. Here we will get all the fully stressed development length also. In IS SP16 also we got this. And how much is the LD development length we need to give, and this is a lap length, how much is a lap length we need to give, and these all things we will get from here. Okay, so this is a excellent code book actually. These are the couplers. Okay, these are couplers. Whenever you just avoid the lapping, so like see, if you have a this one and you can lap like this. Okay, some 45 meter 45 into D, like that. Okay, if you wanted to avoid this lapping, so you just provide this one. You can place a couplers like this. Okay, that the type of arrangements also happen in a site. And again come to here, and this is also, this is how the bending moment, and this is a bending moment for the columns other than discontinuity. Okay, so this is a simply supported bending moment and reinforcement type. Okay, how we can give it, and some of the important things we need to discuss here. It is a beam bending, bar bending schedule, do's and cons, and so we can how we can give the bar bending schedule. Even though if you choose if you see any bar bending schedule details, they will give you like this. This is a rod, how much is the length here, and how much is a hook, and how much is a H+1, L+1, like that we can get it. Okay, so all this, and if you go and again This is also, you have a 200 pages. Okay, this is not easy to study. And here, so some of the clear cover is not less than a 50 mm for the footing. And how much is a cover if it is directly contact with the soil? We need to provide a 75%. And the minimum reinforcement bar should not less than 10 mm. So every time if you are giving the bar, see this. So minimum reinforcement bar will be 10 mm. You can't give a 8 mm bar in this. Okay. So and also here it will show you the 300, but as of site conditions, at least you give a provided 500 mm. You can provide a higher one, but not lesser. If it is a 300, you can't provide a 250. So you need to provide a higher one. Okay, here is a column. This is a general detailing. You need to give detail as like this only. Okay. So otherwise, anytime if the construction that site engineers need to understand our drawings. Okay, minimum percentage of 0% is high strength deformed bars in a footing. And come to the column. These are the combined footings. How we can give it the detailing. This is a slope type of combined footing. And here when we will go for this type of footing, if suppose this column will getting a lesser load as compared to this load, at the time we can reduce the size also, size of the footing. At the time we can go this type of arrangement. And here is a pile system. How we can give the piles, and this is a pile arrangement. Horizontal bars, this is a pile. See this, two piles with the pile cap with the column, one column, right? So like that. And this is a plan view, and this is a elevation view, this is a plan view. And again come to here, and these all the very important, but due to time being, and we will discuss on the column. Okay, how much is the reinforcement, the maximum percent. Everyone will ask you how much is the maximum and minimum percentage of reinforcement. Where we will get this? Okay, in this code book. So shall not less than 8%. All the columns, at least we need to provide a 8%. It should not be less than that. 6% we need to provide a cost. The area of the longitudinal reinforcement should be normally not exceeds the 4%, but cross sectional of the, whenever you are using the lap or anything lapping, so we need to go for the 6%. Then you can study here. Okay. So and what is a bar? So if you provide a columns, so you need to provide a 12 dia at least. Okay, 4 dia. And pedestal, how much is the 0.1% of cross sectional area? You need to provide a pedestal reinforcement. Okay, these are the stirrup arrangements. Okay, stirrups arrangements also main important. And this is the arrangement for the columns. So column will be like this, and here. And once I explain you this, let me show you one of the project actually. So then you are able to understand how we can give. And this is a junction. So every time, if you suppose you wanted to give, if you wanted to give that to the site engineer, just take this reference and you will give site engineer. Then tell that just follow this type of detailing there. Okay, so like that you can follow. And also here is some arrangements of the bars also. So and again, if your minimum reinforcement shall not exceed 0. Tension reinforcement, minimum reinforcement, and these all things. Let me just skip this due to time being. Okay, and this is a slab. So how much is a percentage of the high steel, and the minimum, and the cover, and the diameter not less than 8 mm. And this is also like that. And again, I think it's having a lot of pages, but let me skip this one. And this is how, I hope you understand it, how we can follow the this one. And after that, let me show you this the last one, ductile detailing code book. This is not that much, it's only 24 pages of code book. So even if you want to study more things, and this is a ductile detailing. And see here, minimum grade of minimum grade of concrete shall not be less, shall be M20 or M25 by buildings more than 1.5 meters in height, 15 meters height, seismic zones, and it's not less than the required based upon the exposure conditions. Okay, and it's a beams, and ratio of the actual ultimate strength to the actual 0. Proof strength shall not be at least 0.5. And the beams, if it's a beam, shall be probably depth to width ratio will be 0.3. And like that. And here you can see some arrangements in a plan view, width of the transverse reinforcement, beam column junction, and the longitudinal reinforcement. How much is the longitudinal spacing shall be link not exceeds the 150 mm. Okay, so this is a development length. Okay, anchorage length. And here is the sum of the formulas and some of the bending moment and shear force. And here is a closed strip lasers. But what will happen here? Will this one, this what is that? SP64 show you how we can place this arrangement. So how we need to place. So this is a 50 maximum. I need to give it. So yeah, if you see 50 mm is a maximum, I need to give here. and here is a 2D, and here is a d/2, and these all the information you need to study. And after that, let me go to here. And the columns including the member, minimum dimensions of the column shall not be less than, initially whenever if you want to design the column, so initially you need to follow as per the code book. Once the design will be analysis will be over, so then you can decide which one is the better. Okay, even if you come to here, so this is a, if it is a, suppose the yeah, see this, if when every time the HC this length will be greater than the 300 mm, you need to provide a cross tie. So you need to provide a cross tie like this. Okay, if suppose this will be less than 300, you need to provide a hook like this. Okay, so this hook will look like this one. Okay, so and here is also arrangement, and this is a special confining reinforcement. How we can provide a special confining in this? See guys, what a main important thing is, so if it is a column, so you can observe here, every time wherever you have a junctions, there only you can see the higher reinforcement. In the middle, so you will never get any higher reinforcement. So here also, why? Because it is a ductile detailing with the wherever the zone, the earthquake zone. So if it is earthquake zone, here is a earthquake will be acting. Earthquake is always acting at the beam column junction. So that's why we need to design a weak beam strong column. Weak beam strong column base. At the time, these joints may going to deflect. Okay, deflect, or some stresses will be induced. So that's why we can increase the shear. If it is a earthquake, it is a shear reinforcement, right? Shear reinforcement. If you want to avoid this shear reinforcement, we need to provide a ties, shear ties, stirrups. So that's why we increase the stirrups exactly wherever we are getting in junctions. So earthquake and wind load is mainly acting on the junctions. So that's the main reason why we will provide this type of arrangement. Okay, and again come to here, and again some of the special shear walls. How much is the minimum spacing is shear wall, and how much thickness? 150, 300. A minimum ratio of length to wall thickness is a 4. And after reinforcement, and these are all the things, important things we need to study. And I hope IS 1393 is over, and let me show you the one of the project actually. Then only you can able to understand that. I think come on, my AutoCAD is trying to open, but give me a minute. I hope up to now you understand better, I think. So I hope you understand how we can use the IS codes in the field of civil engineering. So after this webinar, I'm very happy to explain you all these things. It's maybe going stuck actually. Just give me a minute. I hope just let me try to again turn on the AutoCAD. Yeah, it's open. Sorry guys, it's taking too much time actually. I didn't thought that it would take too much time. Come on. Give me 2 minutes of time. Let me show you that. This is the type of arrangement while we are doing the project. I hope you see in my screen. So there you can see the project actually. So this type of project details we need to give to the client when we complete the design. Okay. So every time just remember the things. So first of all, we need to design an architectural plan. Okay. Once you've done the architecture plan, we need to decide the column spacing and these all things. We need to design our building in either ETABS or StatPro. So if it is a RCC building, you will go for the ETABS. So if it is a steel type of building, you need to go for the StatPro. So after once you done the design and analysis, you need to give the detailing. Okay. So let me show you that. This is one of the architectural plan. So once after done the architectural plan, so here we decide the columns arrangement and these things. once you decide the column arrangements, let me go to the ETABS, and then I will design in ETABS, and after that, based upon those results, we will design footings. ETABS will never give you the footing design. We will go for the safe software. So after that, we need to draw this in AutoCAD. Okay, otherwise we have some softwares, RCDC also giving you the drawings and scheduling and the quantity estimation. Those all things that RCDC will give you, but sometimes we will only stick with AutoCAD apart from the RCDC softwares. And this is a footing design, and here is some core lift wall, and here is a scheduling. And again, let me show you. This is a footing type, and once you go to this is a top roof structure and water tank. And let's go to, this is a beam detailing. Okay, so see this, why we will provide this beam design, why we will provide only extra here, why we will provide extra in this middle only. So these all things, as a structural engineer, we need to know that. Okay, so everything is based upon the interlinked SCA, structure analysis, RCC, these all things. And this is a staircase drawing. Okay, and this is a staircase drawing in this, and you can see the staircase, how many plates we get, and how much is the reinforcement we will provide, 10 dia 8 center to center. Okay, so like that you can provide it. And after that, let me show you the architectural plan also. So sometimes we need to do the, as a civil engineer, we need to familiar with the architectural works also. So for that, I think I need to mention you the feedback actually. So my one of the teammate will send you the feedback form in a group in this chat session. You just fill the feedback form. We will give you all these software, this actual means whatever the IS codes we discussed, those all IS codes you will get a soft copy. Okay, so this is the architectural plans. So how we can decide the architectural plan, living room, bedroom, say master bedroom. After this, once the architectural plan will be done, we need to make a columns. Okay, once you done the columns, take these spacings in ETABS, and we will do that. After that, we will design this entire detailing. Okay, I hope this is the actual procedure is following in a consultancies. Actual procedure is following in a consultancies. I hope you understand it. So yeah, if you have any doubts, you can ask right now. Let me try to cover all your doubts. And so I hope you can see the chat box also. You can see the chat box, and there you can see feedback form. Then fill that feedback form. Then you will get all these IS codes, soft copies. And, let me see. Yeah, you can see the, please share the PDF on manual of calculation. So yes, Rajesh sir shared that BBS standard BBS books actually. So by going to that website, you can get all those things. So thank you, sir. Thank you so much for sharing that. And I hope if you have any doubts, you can ask right now. So if you just go to the go and take that form and fill that feedback form, then only you will get all the IS code books. And if anyone missed this session, I will try to give you this recorded session. And before that, let me explain you, if you are not a part of our 𝗵𝗻. So we are also giving you some courses actually. So let me show you those courses. Even though in our website also you can find out those all the courses. So we are mainly giving you the courses regarding on a architectural course, AutoCAD architectural we are giving, and just ETABS course. In the ETABS course, you will get a single story building, and so let me show you that. In single story building and G+1 story building with earthquake and wind load, and as well as we cover the manual calculation also in that ETABS software, and all the manual calculations we teach you there. And after that, G+5 story building BTech project, one of the BTech projects also we will give you. And if you wanted to see the content of our course, complete course, this thing, and you can go to here, and in our website also you can see all the content. Once you click on a click here button, so then you will get all the architectural course and structural course, ETABS course, you will get all the content. Okay, so let me show you those content. Yeah, this is our portfolio, which is our explain you there. And here is the architectural AutoCAD architectural content. So which content you are going to learn here. So initially getting started, so in AutoCAD architectural commands and all the display interface, how we can draw, use the draw panel tools, all these tools you can explain. And after that, Vastu, all about Vastu we will learn here, and client requirements, whatever the client requirements we will learn, and proposed drawing on paper based upon the some government rules as per the GVM's rules, how much setbacks we need to remove, and as per the Vastu, how we can arrange the rooms as per the Vastu. Those things we can learn here. And drafting on AutoCAD, drafting, how we can see this up to here, it will be depend upon the engineer calculation, how we can decide the as per Vastu, how we can decide the government rules, everything will be depends upon the engineering thing. Okay, come to the drawing on AutoCAD, it will be not a designing parameter. Whoever will learn the AutoCAD, they can draw it. Okay, but here whatever you draw in a paper, how we can draw in a AutoCAD, that we will teach you. And after that, working with layout, how we can work with the layout. If you wanted to give it to the client PDF, how we can give the PDF printable drawing to the client, that you can learn. And here also structural outlook also you will learn and study the architectural plan as per Vastu, column placing and orientation, and the different types of slabs, methodology of design and construction, and load transfer methodology in RCC building, design concept for structural components, detailing criteria for bending moment and shear force. How we can so some of the parts I missed this in this IS course webinar. Here I just covered all these things, and this is a complete architectural course actually. And if you come to the ETABS course, and the first ETABS, we have a nearly 4 modules. In this first module, this is the first module. Here in this first module, you will see why and why ETABS and the structural analysis concept. From the BTech second year, we covered these topics, and the books, textbook, and we can compare with manually. So in ETABS, the textbook problems we will do ETABS, and we compare with manually. And the ETABS model explorer, how it will, how we can use the ETABS extension file, how we can import into the DXF file to ETABS. And after that, all the panel options, each and every, if you go for the edit, how many options you have and how we can use those options, those all things we covered here. And after the discussion of the architectural plan, once you've done this architectural plan discussion, you need to go for the step-by-step procedure to do your analysis and design. Step 1, creation of the grid points, and step 2, defining of the property, step 3, assigning of the material, and step 4, assigning of support, defining the loads, and assigning of dead loads, assigning of super dead load as per the part 1, and live load from the part 2, and manual calculation on G+9 story building. Whatever I shown you manual calculation, those things you can cover here in this part 3. And without knowing the manual calculation, how can you assign in a ETABS? Those all things you cover. And seismic manual calculation also we covered, G+3. Okay, part 1, assigning of seismic loads. So G+3 seismic manual calculation we did, and whatever I shown you, that is the main thing. And assigning of load combinations, part 5, and run analysis. Once you run the analysis, we need to perform some important checks: animation check, deflection check, drift and sway check as per the earthquake and wind load, IS code books 16700 as per that we need to check, and the torsional irregularity check. If suppose our building will be having a torsional irregularity, how can you rectify that? So, and axial force and bending moment, and bending moment M3, and these are for the slab design, beam design, column design, how we can take this, and how we can study the story response plots, and how we can study the tables. Those all things we cover here. And after that, run the design, how we can design it. And once the run the detailing, we cover the 2 softwares, ETABS 2016 and ETABS 2018 also. In the ETABS 2016 course, module 1, module 2 and module 3, we cover the run detailing. But ETABS 2018 software in the module 4, so that is a G+5 story building with BTech project. So that we didn't cover any detailing. So after that, outlook on IS foundation design in SAFE, how we can design a foundations in SAFE, those all things also we covered. So some of the outlook, it may be some SAFE also we cover. And after that, essential basics in structural engineering, discussion of design IS codes of the reinforcement concrete structure. This webinar is mainly for my group, my students. So I just make it this is helpful for all the engineers. So that's why I make it for all you guys. So yeah, and after that, design IS codes and steel structures, we already covered this. We already done the previous webinar. That's why we give you this one. And load distribution methodology in building, comparative study of ETABS and StatPro, how we can compare. That also we will discuss. And the sequence of work in a building construction, how the sequence will go. And concrete mix design, that webinar also we will do. Geotechnical investigation report, how we can study the geotechnical investigation report, that we will see. in this ETABS course, and it is ETABS having a nearly 50 hours of session. And come to the AutoCAD structural course. This is a course which is I explain you in AutoCAD structural drawing, right? So this one, yeah, this one. So this is also we are covering, and procedure for these all will be the AutoCAD, learning AutoCAD. And once you learn it, how we can design a slab design and detailing, some of the codal provisions and SP34 and IS 13920. These all things I covered in right now concept. But in that in detail, okay, when we go for the slab, how we can study in a SP34 slab design, and how we can study the detailing. As per that, how we can draw in a CAD, how we can draw the CAD, those things we will discuss. And beam and designing detailing. So rules SP34 and IS 13920, and some of the codal detailing, column detailing, foundation detailing, staircase detailing, these all things. And a discussion on special component detailing, some complete discussion on G+4 story detailing building. So whatever I shown you, right, G+4 story building, that I will clearly explain you each and everything. So from the architectural to giving to the client, that I will explain. And the discussion on combined footing details and the pre-engineering building footing details. So combined footing details is somewhat different, and isolated footing is somewhat different for RCC pre-engineering building. Pre-engineering buildings, we will get anchor bolts and grouting and base plate, these all things. That also we will discuss. And shear wall detailing and retaining wall detailing, UGT, underground water detailing, and overhead water tank detailing. These detailings we will give you on a discussion on those detailing. We will show you how we can detail, and those we will explain. And this is a complete procedure. And if you once you log into our course, we will give you the 𝗵𝗲𝗁𝗂 library access. In that 𝗵𝗲𝗁 library, you will get all the information data, Excel sheets and AutoCAD 2D. If you go to the AutoCAD 2D, some of the 2D drawings and some of the AutoCAD books and 𝗏 rules and regulations, and some of the GOs, some VRDMA GO and MES GVMC GOs and bar bending schedule. Excel sheets also will give you concrete mix design Excel sheets, and the concrete lab test Excel sheet, cement, brick and aggregate course, and understand about the architectural drawings and structural drawings and IS code books, mixed design, lab test and design concepts, Excel sheet. Design concepts, you will get all the lot of stuff actually, how we can design in some of the ETABS model procedures, and design complete column design Excel sheet, beam design Excel, slab design. These all the Excel sheet you will get through my library. And once you come to the fee structure, this is my fees actually. So there's a course fees will be AutoCAD architecture course. We are charging for 1,500 rupees for nearly. We are getting a 20 hours of course. I just I didn't made that change. Nearly we are getting some 15 to 20 hours of course it is, and it is a price. And AutoCAD architectural analysis and design, it is 4 modules. So we learn module 1, we learn about the ETABS, and module 2 we learn about the Jeep single story building with the gravity loads, and G+2 we will learn about earthquake loads and gravity loads as well. G+5 is a BTech structure, BTech project actually. So that also I will include, and here we will get a 55 hours of course. This is a price will be 3,500 rupees. And come to the architectural structural course, nearly we will get a 25 hours of course. It's a 2,500. And here is a combo course. So the come to the combo course is somewhat lesser, and come to the free course, whoever will take the combo course, I am ready to give you the AutoCAD Revit Architectural Structural MVP course free. So it's a nearly 8,000 rupees worth the course. And once you register, we will get a 𝗵𝗲𝗁 library access, and we will install the software whichever you need, and those things you can. And here, if you wanted to see this, and just go to our website. So we will try to incorporate our website in our chat box. Come here, and here. So let me place the chat box here. Paste here, and you can check all the content in our just check the chat box, and there I uploaded my website. There you can see all the stuff what you are going to learn, and how our students will what is the testimonials from the students. Even you can see the testimonials also. How here also you can see some of the MTech students and some of the working professionals also join our course, and they see here is some 𝗵𝗏𝗁𝗂 architects also they joined, and here is some junior engineer working in VR construction, the Mahesh, and like that you can see all the testimonials, and you can see all these things. And I hope this is clear. So if you have any doubts, you can ask right now. If you are excellent, insightful, thank you sir, thank you so much. So if you have any doubts, you can ask me, and otherwise so whoever till you didn't fill the feedback form, try to fill the feedback form. then we will get back you soon. And so if anyone interested to join our course, you can, don't hesitate to contact us. So once you contact, and I think you don't have any doubts actually. So some of okay, some any doubts? Can you please share the PDF manual? Yeah, manual calculations. So I need to share with my students only. So don't worry, please. And after that, yeah, okay. So I hope you don't have any queries. So I hope, sorry for the time delay. So anyway, take care. Bye bye. I hope you learn at least something, how we can use this IS course and these all things. Yeah, thank you. We are happy to explain you these all things. Anyway, see you in the next webinar. Thank you so much. Bye bye.